All right, thank you, Anthony. Good evening, everyone. Glad that, yeah, I think it's evening over in Vancouver too. It's definitely evening here in Toronto. So glad that could be here with you guys. Talk a little bit about spray foam and what's happening with the whole HFC phase outs specific to the spray foam market here in Canada. So kind of starting off at the very beginning and just kind of rehashing or rewording what some other people have said so far. But starting with the Montreal Protocol, signed in about 1987, and this was designed for the phase out of ozone depleting substances, and not just in spray foams, but also aerosols, hairspray, air conditioners, refrigerants, etc. So that was signed in 1987. By 1996, CFCs were phased out and replaced with HCFCs, hydrochlorofluorocarbons. And then those were phased out in 2010. So I got the opportunity to work through and formulate the 2010 HCFC phase outs and got those replaced with HFCs. And now we're working on the HFC phase outs for the end of this year. On the ozone depleting side of things, is everything worked very well with that, going from CFC with a ODP value of 1 down to HCFCs with around I think that's about a 0.1 there. And then both HFCs and HFO have a zero ozone depleting potential. So the Montreal Protocol worked really well with that worldwide. So that's where the Kigali Amendment came in to kind of ride on top of the Montreal Protocol and use the same framework because again, it was specific to blowing agents and refrigerants. So it was actually implemented at the beginning of last year in Canada. And that began with a phase down in what was allowed to be imported into Canada. So there's no actual manufacturer of the hydrofluorocarbons in Canada. Everything's imported into the country, so it's pretty easy to regulate at the border through the border crossings. So that was already begun in January 1st, 2019. We haven't seen it too much in the foam plastic side of things because it was the refrigeration side, especially transportation market, the OEM suppliers. Here in Southern Ontario, they actually did a big phase out and changed over. So that kind of, the phase down in what could be imported, that kind of helped reduce what we as a foam plastic sector needed to worry about. Looking at the GWPs, these are kind of average numbers I put together. So the HCFCs are sitting around the 4,700, GWP 100, HCFCs were around, what is that, about 1,600. Then the HFCs kind of on average is a big range on there, but I just kind of ballparked it and sitting around 1,000. Of course, HFOs, the actual molecule itself is roughly around a GWP of 1, so that's why it's showing up as 0. So the big thing is for foam plastics is they can no longer be used after January 1st, 2021 that contain HFCs. So on spray foam, you'll see this on the next slide. But basically the resin component that has the blowing agents in it is they will expire as of December 31st at the end of this year. We're already in this 10% phase down as I talked about, but that's on imports into Canada, so it's not really affecting our industry. And the typical replacements are HFOs or hydrofluoroolefins. So these are the Honeywell Solstice and Chemours Opteon type of products that are being used in spray foam installations. And BASF, we have our product called Waltite CM01. We've had this commercially available for, I think, about 3 winters now. Winter is a very significant mark because it's these products are applied on site, so it's very critical to make sure that in Canada that the chemistry still works when it's minus 10 or minus 15 degrees Celsius outside. So that's why we're pretty comfortable going in with our Waltite CM01 product and knowing that it's going to perform year round in the market up here in Canada. Where the blowing agent resides is essentially on the resin side. So spray foam is sold to the spray foam contractor with a drum of isocyanate and a drum of resin components. So the isocyanate basically makes up half the material. It goes through a proportioner that measures it 1-to-1 by volume to control the ratio. And then the resin components kind of where all the magic happens with regards to how are you making these products unique and specific and getting the types of physical properties you want out of it. And the blowing agent makes up about anywhere between 10 to 20% of the resin components, so about 5 to 10% of the overall finished foam product. And all these products, they're all sourced in North America, kind of around the Louisiana, Gulf Coast and New Jersey markets. I'm going to talk a little bit about LEED later on as well too, if we still have time. So I just want to kind of mention that a little bit there. So what's changing on the foam properties as they go from HFC versus HFO? As a chemist that formulates this stuff and is very proud of the performance of our HFC products and how they perform in the field, it's pretty critical to make sure that the actual installers didn't notice any difference when they're spraying one product to another. So our product specifically, very, very happy to see that our installers don't notice a difference when they're switching back and forth. On a physical property side of things, not a lot of stuff has changed. The density ranges between the different products that are commercially available are still the same. It's still a gaseous blowing agent that the closed cell spray foams are using. The R value per inch is lower. There's two reasons for that. The first one is just the molecule in and of itself has a slightly lower R value, and it's a slightly lower loading into the resin component, so there's not as much blowing agent in there, so that's bringing down the R value slightly. But also the test method to test the LTTR has also changed along with some of the spray foam standards. So again, I'm just going to do a little bit of a slide on that quickly, but I won't get too much more into that. But all the other properties, such as the air barrier material, vapor barrier, low water absorption, can be used interior and exterior and also provide structural strength. None of those properties have changed going from HFCs to HFOs. So updates to the standards. The old HFC standards were on a 2001 version for spray foam that used, they had some couple amendments in them. That's why there's a 2003 LTTR standard in there. Then with the latest building code additions, the latest spray foam standard is a 2015 standard that references a more exacting or more extreme version of the LTTR standard that's giving a little bit different numbers based on the calculations used. So again, the big differences for the spray foam standards, not completely separate from the HFOs, but it's just the timing's the same. But the more complex LTTR procedure, we removed the initial thermal resistance requirements because it didn't really mean anything in the standard. It was basically being misrepresented in the field where people or spray foam installers were claiming R7 per inch, causing confusion out there. Where the building code essentially is saying you need to use the LTTR values for your design values. You added a fungi resistance requirement and also added some more stringent dimensional stability limits, knowing that there were going to be some blowing agent changeovers, and just to make sure that the products are still continuing to perform in the field as we know that they can perform in the lab. So the 2015 version of the standard, that's in the latest National Building Code, and that's what's referenced as the 770, the latest LTTR standard as well. So all the new code updates that are coming through will be referencing the newest standards, and that's why you're seeing a little bit of a difference in some of the values that are being reported. Getting into a little bit on the use phase before I get into kind of a little bit on the environmental impact. So again, the same advantages are there. So it's got a high R value insulation, provides an airtight seal, and with proper detailing, it can give you an air barrier system throughout the whole wall assembly or the ceiling assembly, as long as you're paying attention to the details on that. It's an effective vapor barrier. I just realized I spelled vapor wrong. This must have been from an American, one of my US colleagues did that. So, it prevents growth of mold and fungi by controlling that moisture, and it's a lightweight insulation, so it does provide less material is required to go in the building to get that insulation impact. So just a couple of highlights of where it can be used in the building envelope very effectively. So this would be the underside of a garage ceiling or a parking garage, essentially just spraying in between the joists or spraying underside of the concrete slab, and then making sure that there's a thermal barrier on top of that to be code compliant. It can be used below grade, both on the exterior and also on the inside of the foundation wall. As long as the drainage plane is there and there's good water drainage, which hopefully you have on your foundation walls, then you don't need to worry about any kind of water absorption. We have research through the National Research Council showing how the products perform very well in these types of applications with very minimal water absorption and no effect on the thermal performance of the foam products. Again, proper detailing there. It can also be used on slab below grade. Here they're using, you can see the radiant floor heating in there before they pour the concrete on there. Again, when it's detailed properly and tied into the wall system, it can be used as a radon control barrier as well too. And again, this is similar to, you get the same performance out of your HFOs as you do out of your HFC-based spray foam products on this. So, and then if you're spraying the basement, you can kind of continue it up on the interior wall of the basement. And effective R value is a big thing now all across the country. People, you know, the builders I interact with, they're still trying to get a grasp on it. Vancouver area is a lot more advanced on the effective R value designs, and in the basement situations, the easiest thing to do there is just move the studs off by about 2 inches off the wall, and all of a sudden you have 2 inches of continuous insulation. You can tie it into the rim joist properly, and a good spray foam installer will detail it to make sure that they get all the air sealing required in there. And then moving over to commercial style buildings. Again, cavity wall insulations out on the exterior, spraying right around the brick ties. One of the advantages of using spray foam in these types of applications, closed cell medium density spray foam, is because it is an air barrier material and a vapor barrier. When you're applied at least 2 inches thick, it's going to seal around all these areas, seal over all those joints. And there's very little requirement for any accessory products to get a complete air barrier system. So as a result, it's basically when you're looking at the EPDs of the overall wall assembly, to get that air barrier system, it really is just a spray foam insulation. You have to look at that for that product value. It's otherwise you're looking at a couple accessory products for transition membranes and a couple of caulkings just to kind of help tie some things in with through wall flashings and window penetrations. And just some more pictures of the cavity wall installations, 3 floors on there, and again going on to concrete block backup. Very common in institutional applications. Getting into steel stud assemblies, again, like Randy was saying earlier, this is an area where it needs to be carefully applied, especially in the winter time where it can be very cold. So again, we're always training my customers, my installers, to make sure when they're applying this that there's a little bit of heat in the building so there's no thermal shock. You can get continuous insulation on the outside. Again, with spray foam, it's a great way to do that as well too, and just add additional R value on the interior. And then the installer needs to make sure that they get their guns into those spray foam channels, into those C channels there. Everything's nice and clean. They spray the foam in there, and then they do their visual inspections afterwards to make sure that there's no cracking in those areas. And then again, getting into some of the concrete, precast concrete buildings, we started to see as well too, apartment type style buildings. And again, they're doing these a lot like they're doing basements where they start offsetting the steel studs from the wall. So you get 1 to 2 inches of worth of continuous insulation installed from the inside before the studs are in there. Gives a little bit more room going into the stud cavity to run electrical afterwards if they choose to do so, and put the drywall in there. So again, a very effective way to add a bunch of insulation value into those concrete walls. And it's just a matter of working out the effective R value calculations for these to make sure that you're getting the markets or the target effective R value that you're looking for on these. So getting into the EPD impact on these, again, Anthony went through this a little bit, just a little bit different presentation on how I'm showing this. So these are taking some of the industry standard EPDs that we can find from ASTM and UL Environmental. And we have our HFC closed cell spray foam. And again, this is the 1 meter squared. The unit for this, for the GWP 100 is 1 square meter at an RSI of 1, which is about a 5.668 R value. So how much insulation is required for that? So you can see the HFC closed cell spray foams. And then moving over to the HFO closed cell spray foams on these industry EPDs, it's going from about a GWP of 20 down to about a GWP of about, I think it's about 4.5 roughly. So it's a 4 to 5 times drop in the GWP use. And that's purely just the chemistry of the blowing agent in and of itself that's doing that. A lot of the other factors that are already in the spray foam is already, there's not a lot of differences between the HFCs and the HFOs. So it's purely the blowing agent that's having that impact on there. you can see a couple other insulation products like the mineral bat and the high density mineral bats too, and kind of what their values are of it. Going into the EPDs, a little bit more in depth on the HFO EP closed cell spray foam. Hopefully you guys, if you're on here, you've hopefully read through the EPDs and are somewhat familiar with them. I did a very similar presentation in Toronto in December, and when I asked a room full of architects who's read an EPD, nobody put their hand up. So hopefully you guys have had a little bit more experience with it. One of the interesting things on the spray foam EPD that I was able to figure out, and I'm by far not an EPD expert, but about between 1 and 2 GWP 100 equivalents are based on the installation using the diesel generator to install the closed cell spray foam. And that's one of the big benefits, is this is a site manufactured product. And so the insulation itself is even lower, but just the fact that it's site manufactured, they're using diesel generators, that's actually contributing to that GWP 100 in there. So it's a very easy workaround with regards to getting rid of that GWP 100 by doing short power to the spray foam equipment, plugging them straight into the building, and then you don't have to worry about, so you can drop about a GWP 1 equivalent off of that value to get a little bit lower embodied carbon with the site install of the product. So some of this stuff, bringing it over to the commercial architectural stuff and where all this comes together with the LEED V4, with the environmental product declaration on spray foam, you get some points for that. So again, the industry has an ASTM, we used ASTM to do our EPD. So if you search for ASTM and EPD-085, it'll go up. Due to licensing requirements, I can't distribute that, or I can't mail that out. I always have to refer people to the ASTM website to actually look at the EPD. Additionally, using health product declarations, you can get credits for that. We're working with HPD Builder to show our product ingredient list, disclosure list, which is essentially a safety data sheet. Then it's a site manufactured product, so you get LEED points for that. And also it's classified as a low emitting material. And this is using the Green Guard and Green Guard Gold standards that a lot of building construction products have these Green Guard and Green Guard Gold stickers on there. So what they actually mean with spray foam and it being a low emitting material. So use a test according to the California Department of Public Health and basically evaluate the materials on a quarterly basis to see what's coming off. Is there anything toxic coming off of these materials? And so something that's properly installed by a certified installer, it's very easy to show that everything's deemed safe by UL Environmental, and that's where the Green Guard Gold certificate comes in. And again, that gets you some LEED points on that. So it seems like I went through this very quickly. I think I got it in around time. I think there's probably a bunch of you that are waiting to go for dinner. So this is at the end for my presentation. Just wait for any questions out there on spray foam.
Yeah, we have one from Janice Ashworth. Janice, can you please unmute yourself and ask the question?
Sure, yeah, can you hear me?
Mm-hmm. Yeah.
My question is just about, I understand HCFC and HCFC 134A and R134A are the same product. I'm wondering if you know R134A being used in a refrigerant purpose, is that also being phased out with this regulation that comes into effect in January?
Yes, that molecule, because it's an HFC, that's being phased out as of January 1st, 2021. So it's not just foam plastic insulation, it's all refrigerants. And Canada's targeting the molecules as opposed to the end use typically on these products. So yeah, that's going to be phased out as well too.
So I guess my follow-up of that is, will the same replacements be used in the refrigerant application as well? Do you know?
Refrigerant specifically, they're going to be hydrofluorolefins, the HFOs, but there'll be different chemical molecules, different specifically chemical molecules, but I think Honeywell is still branding them under the Solstice trade name.
Okay. And the next question actually comes from Randy. Randy, if you want to unmute yourself and ask the question.
Sure. I've gotten a lot of good feedback already on my question through the chat privately from some folks.
Okay.
But I was wondering if you could speak to experience about the workability of the HFO spray foam, pros and cons relative to the HFC.
A lot of it comes down to the chemistry and how much is going into the formulation on it. So also, I can speak very well to what BASF has done. Our chemical team that's worked on our Wall-Tight CM01 has over 30 years of experience with spray foam and formulating. So we're a very experienced manufacturer of spray foam and formulator of spray foam. The product is formulated in our labs in Toronto. And as a result, from our standpoint and our opinion, is our HFO product sprays essentially the same as our HFC products. We've had it on the market for 3 years, and we haven't seen any issues with regards to sprayability of the product and workability from the installer standpoint. And we haven't seen any kind of adhesion issues with it, cold temperature, warm temperature, or anything like that. So our chemists are very proud of what they put together, and we're excited to kind of launch next year with this product.
Okay. And then follow-up question from David DeRose.
Yeah, just Randy brought up the whole item about the thickness of the passes. So is there a change in the thickness of the passes with the CM01 product?
No. So it's everything with HFO foams. There's a lot of misconception out there throughout North America that you can spray these foams thicker and thicker passes because they think it's a little bit cooler. But again, it is based on formulating for 20 years. I can tell you that you still need to spray these foams at 2 inches per pass, specifically to make sure that they meet the building code. You can do specific formulations and use specific raw materials that will reduce the amount of heat developed so you can spray thicker. But then you actually need to get that certified. So it doesn't meet the building code if it's over 2 inches per pass, or if it's designed for more than 2 inches per pass. BASF, we have a existing HFC product that we specially formulated and got tested with CCMC and the National Research Council to show code compliance with it, sprayed up to 5 inches per pass. So it is possible to be done, but you need to make sure that you're doing your due diligence and that the product is actually tested and approved by the appropriate code authority so that you're covered off.
Okay, thank you.
Okay. And our next question is from Mehdi Zahed. Looks like he's not on the call, so I'll just ask the question. Do you see any plant-based insulation coming out on the market?
So can you repeat that?
Do you see any plant-based insulation coming out to the market?
For spray foams, it's going to be challenging to do something like that, especially since the main component or half the finished product is isocyanate, which is an oil-based product. You can use plant-based raw materials or some polyol sides up to, I guess, about 12% of the finished product could be plant-based materials. We've actually had sugar-based polyols in the polyurethane business for over 30 years. It's just it all depends on what you're trying to do. And a sugar-based polyol that works very well in a door foam doesn't necessarily work well in a spray foam because it's not fast enough to set up quickly. And that's kind of typical of a lot of the plant-based polyols, is you can't put a lot of plant-based polyol into a spray foam product and still have it set up quickly. So yeah, it can be done, but it's the chemistry of those polyols aren't necessarily there to take advantage of in a spray foam application.
Okay. And the next question's from Michelle Christopherson.
Okay, hi there. First of all, I wanted to say thank you. I really appreciate the quality of the presentations, spray foam insulation. And
sorry, your audio is a little bit quiet. I'm not sure if we can kind of barely hear you.
Is that better?
Yeah, much better.
Okay, cool. Perfect. Sorry, I just had the microphone out of my face. So yeah, just wanted to thank everyone for the presentations. Insulation's been a topic on my mind recently. So my question, I'm not sure who the best person to ask this to, but generally speaking, looking at the effects of using spray foam insulation on materials when we're looking at recyclability at the end of life. I know that Embodied we're typically talking about early stage, but looking at if you spray something with spray foam insulation, how does that affect its ability to be recycled and turned back into the industry? And I know that sort of EPDs and typically LCAs, each of the inputs or the EPD inputs is considered or is looked at just sort of as one specific product. But I guess there's definitely some product interactions that happen over the building. And so I'm not sure where things are at or where the softwares are at with that, but I'd love to know someone's input on that or if there is any answer yet for that.
Sure. Yeah.
I can start a little bit.
Yep.
Very briefly on the EPD, at least for spray foam, it looks into account and basically it assumes that the product is landfilled at the end of life. So that's where we are today. There is chemical processes available to essentially recycle spray foam or any kind of polyurethane foams in a glycolysis method. It's more a matter of the scalability and supply and demand scenario as far as making it economically feasible to actually recycle it. But it is chemically feasible to do it. It's just a matter of how do you make money at it, I guess, for lack of a better term. It can be done, but things aren't there quite yet from an economic standpoint.
Yeah, and
this is Randy. I would speak to other insulation products as well. I think that there's very little recycling of insulation that happens, period. I'm sure there's a lot of people on the call who have been involved with LEED projects for a while that have construction waste management. And often that, involves demolition of a building as well. And very little, I don't think it matters what the product is. Because even when you have the board products, they're stuck in assemblies with different membranes and tapes and all kinds of other stuff. And very little of it going on in my opinion. So I don't know how much it really counts right now. Hopefully in 50 years, it's a completely different landscape.
This is Paul. I would agree with that, Randy. I think we haven't really seen much regulatory pressure in North America around take-back programs or end-of-life reuse programs, but we're starting to see it become very important in Europe. And I think if we turn and look at what's happening in Europe, I expect that you're going to see something like that happen in North America, probably and hopefully in less than 10 years. But you are seeing the development of take-back programs in Europe. I think it's worthwhile if anybody wants to take a look at that. And just go into the European Union website and just Google construction waste take-back programs, and you'll see that there's a lot being developed there on the regulatory side of things. So we're all going to be forced to do that, at least in Europe, soon. We don't have foam plastics in Europe, but we've got mineral wool in Europe, where we're seeing that become an important aspect of our business planning.
Yeah, and I'll also speak a bit. I think the question was also talking not just about the recycling of the insulation itself, but the interactions with other building components. So steel studs are easily recycled, but spray foam, does that impact that? The recycling of the steel stud. So I think that's a good point. I'll specifically address the LCA software side of things. Within, for instance, a tool like Athena, you can't change end of life scenario assumptions. So they have sort of standard assumptions that they've made more on an industry average basis. Tally, I don't use the tool too much myself, so I'm not entirely familiar, but I don't think you can actually change the end of life scenarios either on that front. And then with one-click LCA, depending on your tier of license, with the highest tier, you can actually change the end of life assumptions. So for instance, if you have the assumption that you're doing something special to enable the steel studs to be recycled in one scenario versus in another scenario, you could actually change that and see what the impact would be on that front.
Great, thanks everyone.
Yeah. Any other further questions? Oh, actually, Elise, did you have your hand raised? I'm not sure if that means you. Yeah, go ahead.
I wasn't sure if that was going to work. Thanks. So in that last presentation, I think I've heard that there's no manufacturers or suppliers of HFO blowing agent in Canada yet. And so that's being imported from Europe. I was just wondering, first of all, are the Canadian specific insulation products that use HFO, do they have specific EPDs that are accounting for that transportation of the blowing agent from Europe? And if so, once we switch to being able to produce the blowing agent in Canada, like what fraction of the emissions or impact from the LCA or EPD of the product would be reduced by not having to transport that in? Or is the EPD really being dominated by the blowing agent emissions itself?
Yeah, so yeah, just for clarification, the blowing agent's manufactured in the US. I think it's out of the Pennsylvania area, I believe. So it's very, it's the EPD is specific to North America. So it's taken in the assumptions that it's a North American based product, including Canada, when it's doing those types of calculations. And also it's kind of like you said, is the impact on the blowing agent right now. When you see the impact when it goes from about 20 with the HFCs down to about 4.5 with the HFOs, that a lot of the GWP impact has been removed just based on the chemistry itself. So it's the blowing agent's always going to be imported into Canada, like a lot of other things that are imported into Canada for polyurethanes. But the actual resin components are typically formulated and blended in Canada itself.
Okay, thanks.